Okay, so the next exercise that we have over here is basically a useful exercise through which we can learn many things simultaneously. And well, I did spend some time on this exercise because it was both interesting and useful, and there was a concept that I needed to refresh in my mind. And so it took me around an hour or so to go through all different possible cases of this problem, and you might think that basically plotting a point in 3D plane is easy based on the description that we did, but those are basically abstract concepts. And then an abstract concept, when you want to apply it to a particular case, what you will find out, sometimes is that it's not really easy to apply those abstract concepts. So here you get to plot a few points in the coordinate plane in the 3D coordinate system, and then use the distance formula and also some concept related to straight lines and collinearity of points and so on and so forth. So the question is, example number 4 is, show that these points, which are P, -2, 3, 5, -2, 3, 5, and Q, 1, 2, and 3, and R, 7, 0, and -1. You want to show that -2, 3, 5, 1, 2, 3, and 7, 0, -1. You want to show P, Q, and R are collinear. So now, first about the collinearity of basically two or more points. First of all, you know that, for example, let's say that you have suppose we are working in 2D plane, for example. In 2D plane, you have your x-axis over here and y-axis over here, and things are pretty simple in here. There is nothing much to there is no complexities here, really. So if I have any 2 points in the 2D coordinate system, for example, this point over here P and this point over here Q, then what happens is that any 2 points which basically lie on the same plane are basically are collinear, because for any 2 points in the same plane, there is basically a line that passes through those points. And well, of course, we can find out what the equation of this line is, which is, well, not important here, but there is definitely always a line that passes through any 2 points in any 2 points that are basically coplanar. So the term for that is coplanar. So if the points are coplanar, meaning that they are on the same plane, then basically they are going to be collinear as well. Because, well, there is always one line that one straight line that goes through those 2 points. Now, when it comes to 3 points, then things get a little bit more complicated. Meaning that in the same XY plane, for example, suppose that you have your P over here, and suppose that I'm still on the same basically plane. Suppose that you have your P over here, your Q over here, and your R over here. And well, of course, you could say that for example P and Q are collinear, or you could say that P and R are collinear, or you could say that Q and R are collinear. There is no problem with that. But you can see that if I add, for example, PQ, if I add PQ to PR over here, it is always greater than QR, and it doesn't really matter in which order you basically add these sides of the triangle together. As long as you have a triangle, as long as these three lines are forming the vertices of a triangle on the plane, then of course any two sides of the triangle that you add together is always going to be greater than the third side. And what that means is that but if you have, suppose that you have, for example, in the same plane, I have this straight line over here, call it L, and suppose that on this line I have a point P, I have some point, for example, Q, and I have some point R over here. So since these lines are collinear, I know that basically PQ plus QR is always equal to PR. That's basically what we know. We always use this concept in mathematics. And of course, the converse of this is true, meaning that if three lines are collinear, then this equation applies to those 3 points. And if this equation applies to 3 points, then the points are going to be collinear. That's something that probably you could prove. I don't know, but I have been using this in mathematics ever since I have been using mathematics. So it must be, I have never actually proved this myself, or I have never actually seen the proof of this anywhere in mathematics, but the proof must be there somewhere, otherwise people would not be using it for such a long time. It must be, I don't know really, but it doesn't really matter. The important thing here is that if 3 points are basically collinear, then this equation applies to those 3 points and the distance between those 3 points. And if this equation applies to the distances between 3 points, then you can say that the 3 points are collinear. You can use it in two different ways, meaning that the converse is also true, so you have no problem to use it. So what that means is that if I somehow know basically where these points are in the 3D coordinate system, I can just simply add them together, and if basically based on this equation that I've written over here, if the distances are the same, if these distances in this manner are the same, then I can simply conclude that the points are collinear. So that's what I'm going to do now. Okay, so now first let's basically plot these points in a 3D plane, and then we will take it from there. So let's say that here is your y-axis. Let's say that here is your z-axis, and this is your, for example, x-axis. This is your x-axis. Now the way that you know that this is the positive z direction, this is the positive y direction, and this is the positive x direction, and the opposite of those directions are negative directions. Now what you want to do is basically first when you want to plot, for example, -2, 3, 5 in your three-dimensional coordinate system, what you want to do is basically first you need to go with the x coordinate of your point. So the x coordinate of your point is, let's say, 1 and 2. I'm sorry, -2 units. So I have to go in this direction. That is -2, and I don't want to write these over here because it will get too crowded. So over here I have -2 on the x-axis, and once you have this number on the x-axis, we said that you have to basically what you want to do. Let me first tell you the process that you need to go through, and then if it's necessary I will explain a few things about other things as well. So of course you want to go basically -2 units along the x-axis, then you want to go 3 units along the y-axis. So along the y-axis, basically you do need to go, of course, in this direction, right? In this direction, parallel to the y-axis. And parallel to the y-axis, and then of course it has to be 3 units. So that is 1, 2, and 3 units over here. Now, since you want to have 3 units over here, basically if you draw a line which is parallel to the x-axis, like this, if you draw a line which is parallel to the x-axis, something like this, the intersection of this line and this line is going to be basically 1, 2, and 3 units on this line as well, because the ratios are going to remain the same. Since this becomes a parallelogram, and on a parallelogram basically the length of this side is going to be equal to exactly the length of this side, because the angles are the same. So what that means is that this is 1, 2, and 3 units exactly along this line. So then this point over here becomes the coordinates of the point, becomes the coordinates of the point -2, 3, -2, 3 on the xy plane, on the xy plane. So now I have my point on the xy plane, and that would be basically a simple point like -2, 3 in a two-dimensional system. And if I were to plot this in a two-dimensional system, I would simply put my x-axis over here, my y-axis over here, and then 1, 2, and 1, 2, and 3, and then this would be my point. This is that exact point over here. Now, what you want to do in addition to that, I mean, the only difference that there is really between a two-dimensional system and a three-dimensional system is that your points, basically, apart from the fact that they have an x coordinate and a y coordinate, they have some height as well, meaning that you have the same xy plane that we have in a two-dimensional system. In a two-dimensional system, you have your x and y, but over here you have no height. It's just a plain basically sheet of paper. But over here you are actually in space, and you can, on this sheet of paper, you can go basically now, as you can see my screen right here, you can actually go inside, you can go through this plane, or you can have a point which is a little bit higher than this plane, meaning that this would be basically your, if I do it this way, for example, this would be basically your z-axis. And this, you can imagine that this z-axis is actually perpendicular to this plane. If you imagine that your xy plane is exactly in the same orientation as the as the screen you're looking at, then this z-axis is actually perpendicular going through the plane. And that's exactly what we have over here, which basically identifies the height of that point from this xy plane that we have over here, and that I can show you over here using probably this over here in the best way possible. So you see that you have this green plane over here. You have this green plane over here, which is your xy plane. Any point you can plot over here, any two-dimensional point you can plot here. But now, in addition to all the possibilities that you have in a two-dimensional system, you can also, basically your points can also have a height over here, meaning that you can go up, for example, 5 units, or you can go down 10 units, and you can basically really do anything in this system as far as a three-dimensional system is concerned. So that's basically this whole system. Now the next step that you need to take here is that, of course, right now this is a point on the xy plane, on the horizontal plane, on the green plane that we just saw. Now you want to basically go up 5 units. So go up means that you need to draw a perpendicular to the xy plane, which would be basically this line over here. This is a line perpendicular to the xy plane, going through that plane in a perpendicular way. And then you want this distance to be 5 units. So that is 1, 2, 3, 4, and 5. And I suppose if I draw a line, which has this having the same slope as the x-axis in this diagram, I think I will get to the same point on this line as well. Although I'm not really sure, because this point starts over here, and you might not actually get the exact point over there, but let's try. And if I put my point over here, and if I extend this line over here, 1, 2, 3, 4, 5, so let's say 1, 2, 3, 4, and 5, you see it doesn't work that way. Really, it does not really work that way. So this much is really enough for this height is enough for that point. And you always end up with basically some height which is a little higher than the actual 5 units on the z-axis, meaning that it looks that way because we have to basically draw these two coordinates on the xy plane, and so it basically goes a little bit higher. But well, it has to be that way because we are kind of mimicking a 3D system. So we have to do something so that we can see things a little bit 3D-ly, basically. So now this point over here is negative 2, 3, 5. Negative 2, 3, 5. That is point P. Okay. Now with the same logic, what you can do is that basically you can plot other points that you have, meaning that you can plot, for example, your point Q, which is 1, 2, 3. So again, you can start with basically the x coordinate, which is right over here. So your x coordinate is 1, this point over here. do it with this color so we don't switch, we don't get confused. So this is 1, and then basically you want to basically from this point you want to draw a line which is parallel to the y-axis, as we did over here. And then the other point on the y-axis, along the y-axis, is 2 units. It's over here. Now I draw a line from this point. I draw a line which is parallel to the x-axis, and you can see that my line will intersect this line at this point. And what that means is that basically this line, this point over here is actually this point 1, 2 on the xy plane. And so if I drop a perpendicular to the xy plane on this point, and then pick 3 units on this line, which is basically 1, 2, and 3 units over here, I will get this point, which is the point Q, So I will get the point basically 1, 2, 3, 1, 2, 3, which is the point Q over here. So this is the point P, this is the point Q, and the point R is basically this point over here. So you want to go 7, 0, and -1. So 7 would be along the x-axis. 1, 2, 3, 4, 5, 6, and 7. So you have this 7 units along the x-axis. And then normally what I would do is that I would draw a line parallel to the y-axis as we did for these 2 points. But since I'm not going anywhere along the y-axis because the y-coordinate is 0, I need to stay here. I'm already on the desired point on the xy plane. So then I can drop a perpendicular right here on the y-axis, and of course the perpendicular has to be this way, meaning it has to go down -1 units. So if I go -1 units down, I will get this point, which is this point over here, which I can call basically R. We can call R with coordinates 7, 0, -1. Now if I draw a line over here, through these 3 points, it would be some line like this, which, as you can see, goes through this point. It kind of goes through this point, and it does go through this point. Now, why I did this whole thing was that, first of all, I wanted to plot these 3 points in a 3-dimensional system so that we can learn how to plot basically points in 3-dimensional systems. That was one part. And the second part was that now, using this diagram, you know where point P is, you know where point Q is, and you know where point R is. And using the logic that we had before about the collinearity of basically points on a straight line, now I can write PQ plus QR. QR is supposed to be PR. If that is the case, then that means that the 3 points are collinear. And so you can calculate now these distances, and then we can decide whether the points are collinear or not. Okay, so now to calculate, for example, this distance PR, PQ. So PQ is then equal to basically we said that if I take if I take, for example, let's say if I take 2 points, for example, P with coordinates x1, y1, z1, and for example Q with coordinates x2, y2, z2, then PQ in three-dimensional space would be equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. And that is basically how you calculate the distance between any 2 points in three-dimensional space. Now, in order to calculate, for example, PQ here, so PQ would be equal to the square root of 1 plus 2 whole squared plus 2 minus 3 whole squared, 2 minus 3 whole squared plus 3 minus 5 whole squared. And that is equal to 3 squared, which is equal to 9. Negative 1 squared is equal to 1. And negative 2 squared is equal to 4. So 5 plus 9 is equal to 14. So that's square root of 14. So PQ is equal to the square root of 14. So over here, PQ is equal to the square root of 14. Now, the next thing that we have is another distance, which is QR. QR is equal to basically the square root of 7 minus 1 whole squared plus 0 minus 2 whole squared plus negative 1 negative 3 whole squared, and that is equal to 6 squared, which is equal to 36 plus 4 plus 16, which is equal to 20 plus 36 is equal to 56, the square root of 56. And 56 is I think 56 is one of those weird numbers that I never have learned. It's not easy to learn. There are a few numbers, for example 53 or 56. These are very close, and each of them, oh, of course, that's 2 times 28. Okay, so that's 2 times 20, so basically 56 is the same thing as 2 times 28, which is equal to 2 times 14. So then square root of 56 would be equal to 2 square root of 14. This is 2 square root of 14. So then QR would be equal to 2 square root of 14. And then the next thing that we have is this distance PR. PR is equal to the square root of this point and this point. So 7 plus 2 whole squared plus negative 3 whole squared plus negative 1 negative 5 whole squared, and that is equal to the square root of 9 squared is equal to 81 plus 9 plus 36 and that is equal to 36 plus 9 is equal to 45 plus 81 plus 45 is equal to 6, and that's 126. This is the square root of 126, and the square root of 126 is equal to 2 times 63 126 is equal to 2 times 63, and 63 is 3 times 21, right? I think we have made a mistake over here. So 7 plus 2 whole squared, negative 3 whole squared, negative 1, negative 5 whole squared. This is 9 squared, which is 81, plus 9 plus negative 6 whole squared is 36. Now 81 plus 10 is, for example, 91, so 99, so that is 90 over here. So 90 plus 36 is equal to 626. And 63 divided by 3 is equal to 63 divided by 3 is equal to 21. 21. Doesn't make any sense. 2 times 3 times 21, and that is 3 times 7. 3 times 7. So I can write this as, so that means that 126 is equal to 3 squared times 2 times 7. So the square root of 126 is equal to 3 square root of 14. So this distance over here, PR, is equal to 3 times the square root of 14. And now if I put all of these things together, what I would get is PQ plus QR is square root of 14 plus 2 times the square root of 14 is equal to 3 times the square root of 14, which is of course true. It is true. Therefore, you can say that basically the points P, Q, and R are collinear. That's basically that. So the next thing that we have is another example. We have still some time here, so we can do that as well. And that is example number 5. We want to know, basically you have 3 points over here. A is 3, 6, 9, and you have B over here which is 10, 20, and 30. Excuse me. Okay, so now basically you have these 3 points, point A, point B, and point C, 10, 20, 30, and point C is the coordinates of that is 25, negative 41, and 5. So you have these 3 points over here. You want to find out whether the vertices are, these points are the vertices of a right triangle. So in order to find that out, so you know that in a right triangle the Pythagorean theorem holds, meaning that you have basically, if this is your right angle, then this side A, this side B, for example, this side C, then of course you know that A squared is equal to, this is C of course, A squared is equal to B squared plus C squared. And so if this relationship exists between the side lengths of the triangle, then of course you can conclude that the triangle is a right triangle. Now, in order to know what to do, basically what to take as a distance and what to square and what not to square, because there would be many different possibilities here. For example, you could take this point with this point, that point with the other point, and so in order to basically know what to do, what points to take together and find the distance between those 2 points, you need to plot those points in a three-dimensional coordinate system, which would be basically something like this. This is your x, this is your y, and this is your z. So now what I'm going to do is, for example, point A is 3, 6, and 9. And as you can see, these numbers are pretty large, so I'm going to take, for example, small scales with large labels, with large numbers, meaning that I'm going to, for example, for example, this is the x-axis, and I'm going to take, for example, this as 10, 20, 30, and your x's go all the way up to 30. Your y's go all the way up to 41. So that's basically 1, 2, 3, and 4. Each of these is 10 units. And your z's go all the way up to 30. Of course, this is negative y, but 1, 2, and 3. 1, 2, and 3. And so now, in order to, for example, in order to find out the coordinates, the location of this point, you can go along the x-axis, 3, 6, and 9. Along the x-axis, you can pick 3 units there. So if that would be, for example, 3 units. And 6 units along the y-axis. So if I draw a line parallel to the y-axis, and 9 units along 6 units along the y-axis, so that would be, for example, this point over here. And then if I drew a line parallel to the x-axis, then this point over here would be 3, 6. Would be 3, 6 on the xy plane. 3, 6 on the xy plane. So this point over here would be 3, 6. Now you need to go 9 units up for the z coordinate of that point. So you go all the way up here, and then 9 units would be basically, if this is, for example, let's take this as 10 units, and then 9 units would be this point, for example, somewhere over here, and but the point would be here. This point would be point A, basically. With the same basically logic, you can plot this point over here, be 10, 20, and 30. 20 and 30. And so 10 along the x-axis, and then if I draw a line parallel to the y-axis, 20 along this line, so 20 would be here along the y-axis. Over here, this would be your point, and then 30 units up. So I would take, for example, 1, 2, and 3 units here, and this point would be the coordinates of the location of this point, the location of point B. And then you would have another point over here, let's say, for example, C, which is basically, let me do another color over here, C, which is 25, negative 41, and 5. So 25 would be along the x-axis, would be basically along the x-axis would be basically 25 would be over here, and negative 41, if I draw a line parallel to the y-axis, actually the other way over here, because the line is that point is negative, and then basically 1, 2, 3, 4, and 5 over here, and 5 over there. Now I can 1, 2, 3, 4, so negative 41 would be this line over here, this point over here, and if I draw a line parallel to the x-axis from this point, the two lines will intersect basically at this point, and then this point would be 25, negative 41. Now I need to go 5 units up, so 5 units up would be somewhere about here, somewhere about there, and so your point would be simply be that point over here, which is basically point C. Now if I connected these points together, I would get this point over here, this point over here, and this point over here. Of course, as you can see, the triangle is not a right triangle. It doesn't really seem to be a right triangle. Of course, you should never trust the diagram that you draw this way. If you want to, for example, if you want to show that basically whether this triangle is a right triangle or not, if you in the diagram, if you get, for example, this triangle over here, you cannot really say that, for example, since this angle really looks like a 90-degree angle, it's actually a 90-degree angle, because your diagram, I mean, however well you do it, your diagram is not going to be you cannot trust it that way. You can just get a feel for example, where the points are and things like that, but you cannot, for example, based on the diagram, say that this point over here, this angle over here is a 90-degree angle, because, well, your units are not perfect, and, well, your lines have all kinds of basically tolerance and so on and so forth, so you cannot really trust it that way. But suppose that, for example, you use some geometry system, like, for example, GeoGebra. In GeoGebra, you can basically plot these points, and then there is a tool in GeoGebra that you can use, for example, to actually measure this angle. And of course, GeoGebra does not look at the angle; it calculates the angle in the background, and then gives you a number, some number over here. So this number is basically coming from algebra. So in that case, then you can, for example, if GeoGebra gives you a 90-degree angle over here, then of course you can trust it, and you can say that, for example, this angle is 90 degrees. Otherwise, if you want to say that, if you want to logically prove that an angle is a 90-degree angle, you have to show through algebra that the angle is a 90-degree angle, or basically whether you want to prove it or disprove it, you have to do that through algebra, not through diagrams. Diagrams are not the tool to do that. So now what I'm going to do is basically well, kind of based on this diagram, I could say that, for example, this looks like a 90-degree angle, or at least the orientation of the triangle is that way. So if this angle was a 90-degree angle, then this side over here would be opposite the 90-degree angle. So then I could write BC squared as a length. BC squared as a length is equal to AB squared plus AC squared. AB squared plus AC squared. And basically BC, AB and AC are basically all lengths. So now, so what we need to do, of course, then we need to logically is that we need to calculate these lengths over here, and then basically see what's going on with these things. For example, BC would be basically the square root of x2 minus the formula is this way. So suppose that you have 2 points, for example, P and Q, with basically P and with x1, y1 and z1, and you have some point Q with x2, y2 and z2. So then the distance between the 2 points would be PQ, which is equal to x2 minus x1 whole squared, plus y2 minus y1 whole squared, plus z2 minus z1 whole squared. So that would be the distance formula in a three-dimensional system. So then in that case, basically, for example, BC would be 25 minus 10 whole squared, plus negative 41 negative 20 whole squared, plus 5 minus 30 whole squared, which is equal to the square root of 15 squared plus negative 61 squared plus negative 25 squared, which is, I'm going to erase this thing because I need the space. So then 15 squared is equal to 225. 61 squared is equal to 61 times 61 is 0, and basically 36. So you have 1, 2, 7, 3, 3721, and 25 squared is equal to 625. And if you add these numbers together, you will get 3721, 625 plus 225, which is equal to 11,1, 6, 7, 13, 15, 1, 4, 5, 7, 1. The square root of 4, 5, 7, 1, which is 9 plus 8 is equal to 17. I think it's divisible not by anything except that if it was divisible by either 7 or 11 or 13 or I don't know, something like that. And of course this is a good opportunity to talk a little bit about those divisibility tests of those less frequently used numbers, meaning that the divisibility test for 2 is easy, for 3 is easy, for 6 is easy, for 5 is easy, for 2, 3, for 4, for example, you can basically somehow use the divisibility test for 2. Or now there is over here there is basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and well, there is also 17, for example, 14, 15, 16, and 17. So for 2 you have no problem, for 3 you have no problem, for 4 you can use 2 2's, for 5 you already know what that is, for 6 you can use a 2 and a 3 basically, so there is no problem there. 7 is a little bit well, weird compared to these numbers. 8 you can use, for example, a 4 and a 2, for example. 9 you can use 2 3's, for example. 10 you can use basically there is a test for that, you already know that. 11 is a little bit weird. 12 is not a problem. 13 is a little bit weird. So actually this one over here. Again, 15 is a little, no, not 15, but 17. So you have 7, 11, 13, and 17. That is basically the divisibility test that you need to be familiar with. And we will talk about that in the rest of this video. But before we do that, I'll take a few minutes rest, and I'll come back with these divisibility tests, see which one we can use over here. Okay, so now in order to test the, basically somehow, if we want to basically simplify this square root of the square root of this number, of course you need to somehow basically factorize it. And in order to factorize it, you need to know by what number it is divisible. For example, when you want to factorize, for example, 42, you know that, for example, since there is an even number in the ones place, then this number is divisible by 2, so you write it as 2 times, for example, 21, and 3 times 7, and so 42 would be 2 times 7, 2 times 3 times 7, and that would be the prime factorization of this number. And then depending on that, you could somehow pull some of these numbers out of the square root function and simplify your square root, basically square root, meaning that if you had, for example, the square root of 42, then you could write it as the square root of 2 times 3 times 7. And then if you had, for example, 2 3's over here, if you had, for example, 3 times 3, then you could, meaning that times 2 times 7. For example, if you had something like this, then you could take the 2 3's out and write it as 1 3 times the square root of 2 times 7. That's basically what you do in order to simplify some square root of a number. So basically, in short, you have to prime factorize your number and see what sort of factors it has. Or you can do that long division, the division algorithm for the square root of a number, which is something that I have forgotten. It's a little bit complicated, and since I don't use it often, I've forgotten that. Sometime I'll try to use that for a couple of examples to remember that as well. But now, about this number 4571, of course you know that this number is not divisible by 3, because this is 9 plus 8 is equal to 17. 17 is not divisible by 3. It's not divisible by 2. Since it's not divisible by 2, it's not divisible by 4, it's not divisible by 5, it's not divisible by 6, it's not divisible by 7. If you want to know whether this number is divisible by 7, what you can do is use the divisibility test for 7. And the divisibility test for 7 is 4, 5. Your number is 4571. So what you do in such cases, to test the divisibility of number by 7, you double the last digit and subtract it from the remaining leading truncated number. Meaning that first you have to truncate the number and take the last digit out, 457. So now you have taken 1 out, and you have truncated your number. And now you need to double this digit, the digit that you took it out. You have to double it and subtract it from the remaining truncated number. Meaning that you write 2 times 1 is equal to 2, so this number minus 2 is equal to 455. 455. Now, still you don't really know if 455 is divisible by 7 or not. Now, if basically when you do this, if this number is divisible by 7, so is this number that you started with. But still this number is a little bit too large, 455. So you need to again do the same thing, meaning that truncate your number 45 and then double this digit. 2 times 5 is equal to 10 and subtract it from this number. 45 minus 10 is equal to 35. And you see that 35 is of course the same thing as 5 times 7. So it is divisible by 7. And it is divisible by 7. So what that means is that if I take my number 4571 and divide it by 7, what I will get is 7 times 7 is equal to 49, 6 times 7 is equal to 42, 3, 7, 5 times 7 is equal to 35, 21, and 3 times 7 is equal to 21, 0. So you see that the number is actually divisible by 7. So you can write 4571 is equal to 7 times basically this number over here, 653. Now 653, you could still probably simplify this number. This is 11 plus 3 is equal to 14, not divisible by 3, not divisible by 2. But let's again test the divisibility by 7 for this number, 653. Truncate the number 65, double this digit and subtract it from the truncated number. 2 times 3 is equal to 6, and that would be 59. 65 minus 6 is equal to 59. 59 is of course 7 times 7 is equal to 49, 7 times 8 is equal to 56, 7 times 9 is equal to 63. So this number is not divisible by 7. And you can see it over here as well. 653. If I divide it by 7, I will get 93.2857 and so on and so forth. So the number is not divisible. Now, of course, it's possible that your number this number could actually be a prime number, and if it's a prime number, then of course it has no simpler factors. But still you can, for example, test the divisibility for 11, for example. So if you have 653, and if you want to know if your number is divisible by 11 or not, so then you have to subtract the last digit from the remaining leading truncated number. You truncate your number, divisibility test for 11 it is. you truncate your number and then just simply subtract this digit from this number, which is basically 65 minus 3 is equal to 62. And of course 62 is not divisible by 11, so this number is not divisible by 11. And of course you can do the same thing again, meaning truncate your number, subtract this digit from this number, and you'll get a 4, and of course 4 is not divisible by 11. So your number is not divisible by 11. Now, you can test the divisibility of number by 13, for example. So 653, and basically to test the divisibility by 13, you need to add 4 times the last digit to the remaining leading truncated number. So basically you have 65 if you truncate the number, and then add 4 times the last digit. 4 times the last digit is 12. Add it to the number, not subtract, but add it to the number. You'll get 7 and 7. And of course 77 is not divisible by 13. So the number is not divisible by 13. 653 divide by 13, it's not divisible. There is divisibility by 17. So for divisibility by 17, 653, you subtract 5 times the last digit from the remaining leading truncated number. So truncate the number 65 and subtract 5 times the last digit. So this is the divisibility for 17. Subtract 5 times the last digit from the remaining leading truncated number. 5 times 0 is equal to 15, and 0, 50. Of course 50 is not divisible by 17, so the number is not divisible by 17. And if I test it here, 653 divided by 17, I'll get some number over here. So and of course there is always the possibility that you can check whether your number is a prime number or not, and usually you can do it using, for example, some website like this. I usually use this website. That's the only website that I know to basically where I can do this kind of thing, just checking for prime numbers. Now the number was 653. If I check it, it says that 653 is a proven prime. That means that I cannot simplify this. I mean 653, the only way that I can rewrite it is that 1 times 653, and that's the end of the story. So then what that means is that I can write this square root as square root of 7 times 653 in case that's required later. So that is that. So that means that BC, the length BC is equal to the square root of 4571, which is the same thing as the square root of 7 times 653. Now the next length that we have here is first you have BC and then you have AB. So AB is basically these 2 points over here. So AB would be equal to the square root of basically 10 minus 3 whole squared plus 20 minus 6 whole squared plus 30 minus 9 whole squared and so this is equal to basically the square root of 10 minus 6 is equal to 7, 7 squared is equal to 49, 20 minus 6 is equal to 14, 14 squared is equal to 14 times 14 is equal to 16, 1, 56, 14, 196, 196, 30 minus 9 is equal to 21, and 21 squared is equal to, I used to know this, 21, 0, 42, 1, 4, 441, 440, 441. And then if you add these numbers together, you get 441, 196, and 49. So that's 15, 16, 1. And that is 8, 9, 9 plus 9 is equal to 18, 1. And 4 plus 2 is equal to 6, 686. So that is the square root of 686. Now the square root of 686, you can simplify it a little bit. You can write this as basically 686 is 2 times 343. 343. And this is 710. I think 343 is divisible by, it's not divisible by 3, but let's check the divisibility, for example, divisibility by 7, for example. And I mean, all I mean to do here is just use those divisibility tests a couple of times, otherwise I wouldn't basically spend any time on this kind of thing. So 343, we said that to check the divisibility test for 7, for example, you double the last digit and subtract it from the leading truncated number. So 34 and double the last digit 6. If you subtract it, you'll get 28. So 28 is, of course, 4 times 7 is equal to 28. So 28 is divisible by 7. That means that 343 is divisible by 7. 343 divided by 7, you will get 4 times 7 is equal to 28. And you have basically 2, 14, 6, 3, and 9 times 7 is equal to 63. So 343 is equal to 7 times 49. And 49 is, of course, 7 squared, so that means that this is 7 cubed. That is 7 cubed. 343 is 7 cubed. And of course, if you have the patience, of course, having the patience is not the real solution. If you really enjoy working on, for example, mathematics, whenever you happen to do something, if you enjoy working on mathematics, of course, then you will learn a lot while you are doing mathematics, meaning that, for example, 7 cubed is equal to 343, and if you do it slowly, patiently, with basically, I mean, if you really want to learn mathematics, then these small little things that you learn along the way are going to be a lot useful when you, I mean, as you go higher in mathematics. Then these little small things that you learn along the way are going to be a lot useful when you get anywhere further in your mathematics. On the other hand, if you just want to basically finish things off and get somewhere, usually you miss a whole lot of points that you usually need later when you are doing more complicated and more advanced concepts in mathematics. So you want to take your time and learn. I mean, if you want to learn mathematics, learn it well. Don't be in a hurry, don't rush yourself, just enjoy the process, really. Otherwise you will really miss the point. The point is not to finish mathematics, because nobody has ever finished mathematics, and mathematics has always gone a little further, I would say, from the last 6,000 years. So nobody has ever, in the whole history of humanity, has ever finished mathematics. So chances are that you cannot do it either. So now that you cannot finish it, so why not just enjoy it, enjoy the process? And if you don't enjoy it, don't do it. It's very simple. Do something else that you enjoy. But, well, now, so 343 is, so basically 686 is equal to 686 is equal to 2 times 343, and 343 is the same thing as 7 cubed. So that means that 686 is equal to 2 times 7 cubed. So then I can write this as 2 times 7 squared, and then the square root of 686, I can write it as the square root of 2 times 7 squared. And now I can take this out, write it as 7 square root of 14. And that's basically this number over here, 7 square root of 14. So this length over here would then be, this length AB is equal to 7 square root of, is equal to 7 square root of 14. So that's the next one. Now the next one over here that we have is the distance AC. So AC is equal to the square root of A and C, these 2 points. x2 minus x1, 25 minus 3, 25 minus 3 whole squared, plus negative 41, negative 6, negative 41, negative 6 whole squared, plus 5 minus 9, 5 minus 9 whole squared, and then you have 25 minus is equal to 22, 22 squared is equal to basically 44, 0 and 44, so you have 484, so that's 484, that's negative 47, so 47 squared is equal to 47 times 47 is equal to 49, 28, 32, 4 times is equal to 28, 2, 16, 18, 9, 0, 1, and you have basically 8 plus 4 is equal to 12, 1, so you have 2209, 2209, and that's negative 4 squared, which is equal to positive 16. So that is basically that. And then you have 2209, 484 and 16, which if you add them together you'll get 19 here. 1, 0, 1, 4 plus 3 is equal to 7, and 2709. That's the square root of 2709. Now the square root of 2709 is equal to it's divisible by 3 because that's 9 plus 9 is equal to 18. 18 is divisible by 3, so I can write 2709 divided by 3 is equal to 9 times 3 is equal to 27,0093. So that's 903. So 2709 divided by 3 is equal to 903. Again, this is divisible by 3, so 903 divided by 3 is equal to 301. 3, 9, 0, and 1, 301. 3 times 301, and I think this is a prime number. 301 is not a prime number. Oh, it's divisible by 7. By 7. Okay. So 301. So if I truncate the number as 30 and then multiply the last digit and subtract it from the number to check for divisibility by 7, I get minus 2 is equal to 28. 28 is divisible by 7 is equal to 4 times 7. So this is divisible by 7. Now 301 divided by 7, you will get 4 times 7 is equal to 28. And 3 times 7 is equal to 21. So you have 43 times 7. 43, 7 times 43. So I can write this number 2709 as 3 squared times 7 times 7 times 43. Which means that the square root of 2709 is equal to the square root of 3 squared times 7 times 43, which is equal to, I can take this one out, so I can write this as 3 square root of 7 times 43. 3 square root of 7 times 43. So this is 3 times the square root of 7 times 43. So this distance over here, AC is equal to 3 square root of 7 times 43. And you see that basically I wrote these numbers on purpose this way. I wrote these numbers on purpose this way. You can see that over here I have a factor of 7 under the square root function, and here I have a square root, a 7 under the square root function, which can come in handy depending on the kind of operation that you want to do on these. You can basically do some simplification if you know what your numbers are, or basically how your numbers are the factors of your numbers, basically. So now let's check what these values are. So now BC squared is equal to basically the square root of 7 times 653 whole squared, which is equal to 7 times 653. This is BC squared. AB squared is equal to 7 square root of 14 whole squared, which is equal to 49 times 14. 49 times 14. And I'm not really going to do anything with these numbers because you will see shortly why. And AC squared is equal to 3 times the square root of 7 times 43 whole squared, which is equal to basically 9 times 7 times 43. Now, AB squared plus AC squared, AB squared plus AC squared is equal to basically 49 times 14 plus AC squared, which is 9 times 7 times 43. Now, over here I can take a 7 out, so I can write this as, for example, 49 times 2 times 7 plus 9 times 7 times 43. Take a 7 out and write this as 7 times 49 times 2 plus 9 times 43. And 49 times 2 is equal to basically 98. 98 plus 9 times 43 is 9 times 43 is equal to 27, 2, 36, 38, 387. 387 times 7. Now 387 plus 98 is equal to 15, 1, 18, 1, 485. 7 times 485. And 7 times 485 is equal to 7 times, that is 35, 3, 56, 59, 5, 28, 33, 3,395. And AC squared is equal to 63 times 43, 43 times 63, 9, 18, 12, 1, 24, 25, 9, 0, 1, 7 and 2, 2709. This is equal to 2709. So you can see that AC squared is not equal to AB squared plus AC squared plus, AC squared, AB squared. No, I made a mistake over here. So BC squared. No, I made a mistake over here. I'm sorry. So over here we had BC squared. So BC squared is 7 times 653 times 7. 21, 2, 35, 37, 3, 42, 45, 4571, 4571. And of course it's not equal to this number over here. So then you can say that BC squared is not equal to AB squared plus AC squared. And that means that the triangle, or you can say that the points basically A, B, and C are not the vertices of a right triangle. So that is basically this question over here. 2709. So let me just see if my answers are correct here. So AC squared is equal to 2709, which is correct. BC squared is 4571, which is correct. And AB squared is equal to this thing over here, which must be 686. 49 times 14, which is correct. So the answers are actually correct. There are no problem in calculation. Well, now that we have taken the time to offset of points P such that our points respectively. Okay, I'm going to end this video here. We have one more example over here left. We will do that as well, and then we will get to the rest of the things. So I'll see you in the next video.